Welcome to True Projects. In this video, we are going to explain about the project that is a Bayesian optimized deep learning approach for accurate state of charge estimation of lithium ion batteries used for electric vehicles application. Before getting into the execution, first let us understand what is the project about. Energy saving and emission reduction technologies, they are becoming more essential as we face climate change, rising greenhouse gases emissions, and environmental degradation. Global efforts like Paris Agreement and COP26 they are pushing for sustainable solutions and electrical vehicles with lithium ion batteries which are big part of that. These batteries are favored because they are efficient and store a lot of energy, which is key for electrical vehicles. But but for these batteries to perform well and safely, we need to know their exact state of charge. We need to know their exact state of charge. This is where battery management system, that is BMS, comes in as they help to estimate the SOC. However, estimating the SOC isn't straightforward. Batteries are complex systems which are chemical reactions happen constantly. And these reactions can be affected by things like temperature or how the battery is being used. Traditional methods for SOC estimation like Kalman filter have their own challenges. They need very detailed models and a lot of fine tuning, which can sometimes be a bit tricky and not always accurate. So while we have good batteries and systems in place, making sure they operate safely and efficiently requires constant work and better ways to estimate their SOC. So coming to machine learning techniques like SVM, that is support vector machine, and ANN, artificial neural networks, have been tried for estimating the state of charge of batteries, but they come with fewer challenges. That is one of the main issue is that these models rely a lot on manual feature engineering, meaning that we have to hand pick and process the right inputs for the system, which can be time consuming and difficult. And also, these methods sometimes struggle when dealing with the high dimensional data where there is a lot of information coming in the form of different sources, making it harder to get accurate results. And coming to deep learning models, especially recurrent neural network like LSTM, GRU, and BiLSTM, excel at handling complex data and automatically extracting features. This makes them powerful for SOC estimation. However, they still face challenges such as difficulty in fine tuning hyperparameters and adapting to varying conditions like temperature or load changes. Addressing these issues is crucial for improving battery reliability and efficiency, which is essential for the safety and sustainability of electric vehicle batteries. So, to overcome all these issues, this project proposes deep learning models which are tuned by the optimization techniques for estimating the state of charge in the lithium ion batteries, particularly for electrical vehicles. The idea is to make these estimations more accurate and reliable no matter what environmental conditions the battery is operating under. To do this, the system incorporates multiple deep learning models that are RNN, that is recurrent neural network, LSTM, that is long short term memory, gated recurrent unit, that is GRU, and bidirectional LSTM, that is BiLSTM. These networks are great for capturing the complex patterns and relationships between different battery parameters like current, voltage, temperature, and average voltage. So now the system doesn't just throw these models at the problem and hope for the best, it optimizes. So here we are doing optimization to these models by using the Bayesian optimization technique. This is the main proposed thing in this project. So all the deep learning models are optimized by the Bayesian optimization technique. It optimizes them using technique called Bayesian optimization. This way of this is a way of automatically fine tuning the settings of hyperparameters of the model, which typically would require a lot of manual effort for time consuming search models like grid search or random search. The system is tested using a data set where the temperature is set for 10 degrees Celsius and the number of hidden neurons in the model is varied to see what works the best. This approach ultimately aims to make the SOC estimation, that is state of charge estimation process, more efficient and accurate, enhancing the overall performance of the battery management system. And to further improve the performance, here we have incorporated CNN2D, that is convolutional neural network 2D algorithm, to further improve the performance. The key advantage of CNN2D is its ability to optimize feature selection, which helps the model to focus on the most important data. It does this by 2D convolutions to process the data and max pooling 2D layers to refine the features. This results in more accurate predictions as it reduces both RMSE, that is root mean square error, and the maximum error when it is compared with the previous RNN based models. Additionally, on top of that, we have created front-end interface using Flask, which allows users to interact with the system and test its performance directly. This interface includes search authentication, so only authorized users can access and evaluate the system. By adding this feature, we are not only improving the model's accuracy but also making it easier for users to engage with and assess the system. To implement this project, we have followed the steps mentioned in the flow of work. So, first, we have imported the required libraries and packages which are important for data manipulation, model building, and visualization. Then comes the exploring dataset. That is, in this step, we load and inspect the dataset containing battery data of 10 degrees Celsius. This helps in understanding the structure, types of the data, and identifying any issues like missing values or outliers. Then comes the visualization part. Visualization techniques such as graphs and charts are used to explore patterns and relationships in the dataset, allowing us to better understand how features like current, voltage, and temperature affect the state of the charge. Then comes data processing. Here, any repeated or duplicate entries in the dataset are removed to ensure the analysis is based on unique data points. Then comes drop cleaning. Here, we clean the dataset by dropping irrelevant or unnecessary columns that do not contribute to the accurate predictions. After that, we select features that is X variable and that will be used to predict the target that is Y variable, which is in this case state of the charge of the battery. Then comes splitting the data set. The data set is divided into two sets. One is training set and the other one is testing set. It is divided in 80 is to 20 ratio where 80% of the data is assigned to training and 20% is for testing. This ensures that model is trained on one proportion of the data that is training set and tested on the testing set to evaluate its performance. Then all the models which are built in this project are initialized and the initialized models are trained on the training dataset. During this phase, the model learns the patterns, relationships between the input features and the SOC, that is state of the charge. And then they are evaluated using RMSE and MAE to determine which model provides the most accurate predictions. And we have compared them through graphs. Coming to the part of front end, a user interface that is UI is developed during Flask using Flask, which is a Python web framework. This frontend allows users to interact with the system, input data, and receive predictions. And in the front end, users they will be able to provide the input as feature values that are current, voltage, temperature, etc., which are battery related features. And that input will be pre-processed at the backend, such as scaling, cleaning, to match the format expected by the trained model, and it will be fed with the train model. Finally, the state of the charge predicted by the train model will be displayed in the front end of the application to the user. So this is how we have implemented the project. Moving on, these are the algorithms used to predict the SOC, that is state of the charge for the vehicles, that is electrical vehicles. So all these models are tuned, that means they are optimized by the Bayesian optimization technique to optimize the performance, to get the highest performance. Coming to requirements to implement this project, we need hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB, and hard disk of 25 GB. And coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. Because we have completed the overview, so this is the overview of the project. Now it's time to execute. For that, we are supposed to open the code folder. Let's open the code folder. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? First, let us open the dataset folder. So this is the dataset file that we have used in this project. So these are the different features related to electrical batteries. So using these batteries, using these features, we will be training the model to predict the SOC, that is state of the charge. Let's close this. And this is the test data. In this, we have test cases that we will be using in the front end to predict the state of the charge. Let's get back. And in this model folder, we have .h5 files, numpy files, pickle files. In that, algorithm information has been stored, and that will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook file. This is the Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. To execute, we need to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open command prompt. It has been opened. Now give the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. Now we are supposed to compile app.py file. So give the command python space app.py and now click on enter. So what will this command do is it will execute Python script and it will perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. Just wait for a while. It is loading. Here we got the link. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. So open the Chrome, paste the link, click on enter. This is the web page of the project which is displayed in the browser and this is developed using Flask framework. We need to sign up first. So click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in. Here we are supposed to give the username and the password. So give your username and the password. I have given my username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here you can see a box, right? In this box, we are supposed to give the input that test cases we have in the test data files. Open dataset folder, open the test data. So these are the inputs which will be considered. Based on these only, state of the charge will be predicted. Let us understand what are these parameters. First parameter we have is the voltage. This represents the electrical potential difference across the battery terminals. It indicates the current energy level of the battery and it is crucial for estimating state of the charge. Then comes current. This measures the rate of the flow of electric charge within the battery. It helps to determine whether the battery is charging or discharging and provides insights into the energy being used or stored. Then comes the temperature. The temperature of the battery that affects its performance and efficiency. Extreme temperatures can alter the battery's voltage and current characteristics, impacting the state of the charge estimation. Then we have is the voltage average. This is the average voltage over a certain period. It helps smooth out short-term fluctuations in voltage and provides a more stable indication of battery's overall charge rate. Then the last parameter we have is the current average. Similar to voltage average, this feature represents the average current over time. This helps to assess the battery's usage pattern, whether it is under heavy load or light discharge, and aims to improve the accuracy of SOC predictions. So this is all about the parameters. Now we are supposed to give them as input. So first, let's copy the first case. Let's copy the case, get back to the application, paste it here, give the comma after each input. Give the comma and remove the space. Now click on upload. So this input will be pre-processed at the backend and then we will be getting as a prediction. So this is the case that we have uploaded and here we got the predicted state of the charge value is 0.1441973. This is the predicted state of the charge value. Now let's check with the one more case. Now let's try with this case. Copy it, get back to the application. give the commas in between. So the first one we have is the voltage. After voltage, we have is the current. This is the current. After that, next we have is temperature. So this is the temperature that we have is 12 degrees. And next we have is the voltage average, that is 4.00. And last we have is the current average. Now click on upload. So this input will be pre-processed and then we will be getting the prediction. So this is the input that we have given. For the given input, here we got the prediction for that particular battery as state of the charge value would be 0.236. For the battery values containing all these values, all these features will have state of the charge predicted as 0.2362708. Now let's check with one more case. Get back to the application. Let's copy it. Now get back to the application, paste it. So voltage we have is 0.67 and the next value is current. Current is minus 2.12 and this is the temperature. And here we have is the voltage average, that is 3.78, and the last one is current average. Now click on upload. So for given battery values related to these features, that is voltage, current, temperature, voltage average, and current average, here it has been predicted as state of the charge would be 0.984. 0.984. Let's try with last case. So let's try with this one. I think we have done this. So let's try with this one. That is the second test case. Copy it, get back to the application, paste it. You can enter one by one also. So now click on predict. Here for the given set of values, here we got the state of the charge prediction as 0.15651,847. So this is the predicted state of the charge. Now let's check with the graphs. Click on graph. So here the first graph which we have is the forecast of the extension model, that is CNN 2D state of the charge prediction graph. Here on x-axis we have test SOC data and on y-axis we have SOC prediction. And red color line represents the true SOC and green color represents predicted SOC. If you observe both the true and predicted SOCs, they are merged together. It means that actual values and predicted values, they are the same. By this we can understand that extension CNN 2D is accurately predicting the state of the charge of electrical vehicles. So by this you can understand that CNN 2D model is performing well. And here we have RMSE comparison graph. Here on x-axis we have RMSE score and on y-axis we have algorithms that are trained on the data for predicting the SOC. And here we have error rate. Here on x-axis you have model error and on y-axis we have the algorithm names. Here if you observe in both the graphs, error rate is extension model CNN 2D has the less error. Now click on sign out. In this way, just by giving input values to the system, it will predict. That means you have to give the exact parameters that system required. So based on that, you will be getting accurate predictions of SOC, that is state of the charge. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.